We are Kenya Roof It. We are an engineering and community service project. So first off, we'll introduce ourselves. There's Hai Tran, otherwise known as Joey Tran. He is team leader and he is majoring in biomedical engineering. He is a first year at ASU. Next is Tanner Flake. He is deputy team leader. His major is chemical engineering and this is his second year at ASU. Next is Ryan Castellano. He is communication officer. He is studying mechanical engineering and this is also his second year at ASU. Anush Morella is our sustainability officer. She is a material science engineering major and this is also her second year. Kayvon Kavari is our treasurer. He is studying chemical engineering and he is a sophomore. And last is Taylor Rumsey. He is research coordinator. He is studying civil and environmental engineering and this is his first year at ASU. So our goals as Kenya Roof It is to create a new roofing solution. Previous roofing solutions were very expensive and they were ineffective at doing what they were supposed to do. So the perfect ideal roofing solution would be one that is both insulative, cost-effective, weatherproof, and easy to create and maintain.
This project is dedicated to people in Africa, specifically those in Kenya and Malawi. Currently, their roofs are made of sheet metal, which is hot, doesn't have very good insulation, it's really loud, and just doesn't hold up very well. They're made of scraps of different materials to fill in the holes, and they're just not adequate right now. Here are a few pictures of their current situation in Africa. This shows that they're made of sheet metal and that they're not durable. This shows the various materials that are just thrown on top of the roofs. And here again shows another sheet metal roof that is currently in Kenya.
Our community partners are Jan Snyder. We looked into him because he's been to Kenya and he's seen the type of problems they're having with their roofs. He's also worked on G3 Box, which was a medical shipping container, basically a shipping container turned into a medical room, and then he's also ASU faculty. Another person we've been working with is Barzan Mobashar. He is in the Department of Civil and Environmental Engineering, and he is going to guide us for some structures and materials for the roof solution. And Elsa Saldivar, she created a really cool solution for people that needed structure in their homes and didn't want to spend a lot of money or use a lot of resources. And she had combined loofah and broken down plastic to make some pretty sturdy walls.
And for our projected timeline, we wanted to create a possible prototype this semester, and we wanted to test and improve upon it next semester, and then more improvements will hopefully be in progress the year after, and then the year after that a delivery system will be likely. And our current prototype, like some of these materials are placeholders right now, and so we're aiming for like a layered roof with aluminum for the outer layer, rubber which makes it waterproof, chicken wire as a substitute which gives the roof structure, and water balls and loofah mainly for insulation, and another layer of chicken wire to hold everything together, and the base which is already in place there. And these are some similar ideas with respect to the walls, and they all kind of summarize what I was just kind of saying.
Okay, so the goals for our semester were to research the starting materials and the properties of the loofah in terms of insulation, and we had to raise money for the first round of testing. And so in the first round of testing, we had to place a control, which was the loofah in the bottles, and the variables, which is the varying temperatures and humidity. So from these experiments, we were to analyze results, draw conclusions, and then reassess the goals for the next semester. And then we also were expanding on Elsa's ideas to reapply them as our own in this roofing solution, and to focus on creating a structurally sound and weatherproof roof by using loofah as a replacement temporary insulator. And we had to also consider a new solution completely based on local flora. And fundraising, we considered the Edson grant to provide funding, office space, and mentorship to ASU student entrepreneurs. So we felt like we would have a better chance with this than the other ones. But we also considered 10,000 solutions at Changemaker, where we would win up to $10,000 to fund our project solution. And there was also a Do Something Seed grant, which was for $500, and applications were reviewed every 3 months. And it's where community action grants are given to young people with sustainable ideas. And we were also going to look at other possible scholarships and grants.
So recent development is we've been talking to Brittany Duong. She's the president of ASU's Engineers Without Borders chapter. They have done multiple different kinds of community service in Kenya, and so for every summer they visit Kenya and they do things there. So like last summer they developed a water system to hold water, to catch rain. And so they have lots of first-hand experience in Kenya, and they have valuable first-hand information on what can be expected from Kenya, such as what can be bought from hardware stores and other stuff like that. Also, we've been trying to contact Barzan Mobasher, but we've sent multiple emails, but he only responds to some, and we've tried to set up meetings, but he also does not reply to those. So we are still in progress of trying to talk to Barzan Mobasher.
Over the last few weeks, we began prototyping the experiment to see and test exactly what the insulative properties of loofah were like inside the water bottles. And so our experimental apparatus consisted of a heat lamp, a cup of water, and different insulative materials, where we measured the temperature of the water after a given period of time, measuring it every 5 minutes usually, and it lasted for a few hours. And here are some pictures of our experiment. And for our results and conclusions, we determined that loofah was actually a pretty good insulator, as the water beneath the loofah in the water bottles was 5 degrees less than the uninsulated water and 7 less than the water beneath the sheet metal. Although this is solid data, we feel that we might need to redo some of these experiments next semester because of interfering variables like having the room temperature change and not being able to control that, and also having to use different heat lamps on the different days we were doing experimentation. And what's next? So we will continue to test loofah for its insulation properties, improve upon current prototype ideas, and hopefully discuss more with Elsa, our mentors, and Jan Snyder, and planning for the next phase in the project, testing and initial implementation.